Good morning, students. Today we are going to discuss few important topic from the chapter 10, and the chapter 10 from the physics portion is your light, and it has two parts. One is your reflection, another one is your refraction. Now this few term which we are going to discuss, I think most of you know. Now the first term which we are going to discuss related to the spherical mirror is your pole. So as per the definition, it says that the center of the reflecting surface of a spherical mirror is a point called the pole, and it is denoted by P. So you see in the figure, P is a point and it is a midpoint of the reflecting surface. Now here in the diagram we have shown the convex mirror, and P is the midpoint of this reflecting surface, and the reflecting surface is outward and non-reflecting surface is your inward in case of convex mirror. So P is a point which we define as a pole, and P is the midpoint of this reflecting surface. Now the next term is your center of curvature. Now already we have defined that a spherical mirror is a part of a sphere, and a sphere has its center. So that center is nothing but the center of curvature of the spherical mirror. So what we have written, the center of the spherical surface of which the mirror is a part is called center of curvature. So C is the center of curvature, and we have shown in the figure spherical surface, and also we have shown a part of this spherical surface is your convex mirror with a non-reflecting surface inward and reflecting surface outward. Now similarly, next term is your radius of curvature. So again, as the spherical mirror is a part of a sphere, and the sphere has its radius, and that radius is nothing but the radius of curvature of that spherical mirror. So as per the definition, let me read out. The radius of the spherical surface of which the mirror is a part is called radius of curvature, and it is denoted by capital R. Now next term is your principal axis. So how do you define principal axis? It is a line that passes through pole and center of curvature. So the line that passes through the pole and center of curvature is called principal axis. So these are a few important terms, and I think most of you know, but we are repeating here as it is included in your syllabus. Now next one is your focal length. Now if you want to know focal length, you must have to know what is focus. Now if you take a concave mirror and if you try to focus the sun rays, you will see that it is possible to focus all the rays that strikes on the concave mirror, and for that you have to take one screen, and the screen is nothing but a paper. Now what you will do, you will try to focus the sun rays on a paper, and paper seems to be the screen. So you have to adjust the concave mirror such that a bright spot form on the paper. Now you try to increase the intensity of that bright spot. You will see that for a particular position of your concave mirror, there may be the possibility that the paper may get burned, and that position of the concave mirror from the screen is nothing but the focus. Okay, so let me try to define by the statement. Focus is a point on the principal axis of the concave mirror where reflected rays converges if rays incident on the mirror parallel to the principal axis. So you see some rays strikes on the concave mirror parallel to the principal axis, and after reflection it converges at a particular point, and that point is nothing but the focus. And the distance between pole and focus is nothing but the focal length. The distance between focus and pole is known as focal length of the concave mirror. So this is in case of concave mirror, and let me try to define in case of convex mirror. Convex mirror basically a diverging mirror. So let me try to define. Focus is a point on the principal axis of the convex mirror where the reflected rays appear to converge. It is not actually converges, not it. It appear to converge if rays incident on the mirror parallel to the principal axis. And definitely the distance between pole and focus is nothing but the focal length. Now Next topic, let me try to define. This is very important one, and sometime in exam it is asked, or it's a very important point. Aperture of the mirror. So what we have written, the portion of the reflecting surface of the mirror is known as aperture of the mirror. So if you consider this diagram, Mn is the aperture of the concave mirror, because this is the portion of the reflecting surface. Now next topic, maybe this derivation is not included in your syllabus, but I am trying to put it here. In exam, what you have to do, you have to simply use the relation. You are not supposed to derive the relation, but I am trying to derive the relation. Probably a few new things you will get. Please try to understand. Now you see here we have given one concave mirror, and a ray strikes on the mirror parallel with the principal axis, and after reflection it passes through the focus F. Now where it strikes, that is the point M, we have drawn a normal, and that normal must passes through the center. Now why it must passes through the center? Because all of you know the radius and circumference is perpendicular to each other, is not it? And the radius passes through the center. So any line which is perpendicular to the circumference, that must passes through the center. So here we have drawn the normal, and normal, all of you know, it makes 90 degree with the curved surface. So MC is your normal, and you can say this is your radius, and C is the center of the spherical surface of which the mirror is the part. So parallel rays strikes, and after reflection it passes through the point on the principal axis, which is nothing but the focus. Now what we have done, we have constructed a little bit. We have drawn a perpendicular Mn on the principal axis from M. Now if this is the normal, then as per the laws of reflection which we have defined last class, I equal to R, no? Angle of incidence is equal to the angle of reflection. Now if you consider the diagram, we have given I equal to R, and if you consider the parallel rays, then the principal axis and the parallel rays are both parallel, because the rays incident parallel to the principal axis, and you can consider MC is the transversal. If you consider MC is the transversal, then NCM is also your I, is not it? Alternate angle. So that one I equal to R from the laws of reflection, and that one is your R, that one is your I. So if you take the angle M and F, then this is your external angle. So exterior angle is equal to the sum of two remote interior angle, that is your I plus R. And I equal to R, so you can substitute I plus I, that is your 2I. Now in triangle, if you consider triangle M and F, N is your perpendicular 90 degree, Mn is perpendicular over the principal axis. So if you consider the triangle M and F, and I think this is the new thing you are going to get, and some of you know 10, that is your trigonometric term. If you consider MFN, this right angle triangle, MNF, this is your right angle triangle, and if you consider the angle MFN, which is your 2I, and if you take the tan of 2I, then the formula is your like this, which you have given here, tan theta equal to perpendicular by base. So if you consider this value, tan of MFN, so the perpendicular is your what? Mn, and base is your what? Fn or NF, whatever you say, that is your Mn by NF. And again, if you consider the right angle triangle MNC, so tan I again goes your perpendicular Mn, and base is your what? NC. Now in case of trigonometric value 10, this formula again you have to know, tan theta equal to theta if theta is very small. Now here we are assuming that the angle I and R is very small. So you can assume that tan of 2I is your 2I, and tan of I is your I, as per this notation, tan theta equal to theta. This thing you have to know, and probably you will get this thing in mathematics in your trigonometric part. That's why the derivation is not included, but I'm trying to show you here if you are interested. So we have got 2i equal to mn by nf and I equal to mn by nc. So both sides multiply with 2i to mn by nc. So in place of 2i we have substituted mn by nf. So 2 mn by nc. So mn goes off. So what you will get, nf equal to nc by 2. But you see nf and pf are same under the condition that the ray strikes on the mirror very close to the principal axis. So two limitations we are considering. One, we are considering that angle is very small, I and r, and another one we are considering that the ray strikes on the mirror very close to the principal axis. So under that case you will get nf is equal to nothing but pf and nc is nothing but is your pc. So nf equal to pf, so if it is pf then it is your focal length, and if it is your pc then it is your radius of curvature, that is your r. So if you substitute 4 in 3, what you will get, in place of nf this is your f, and in place of nc that is your r. So f equal to r by 2. And in your syllabus in class 10 you have to use this relation in the numericals, f equal to r by 2. I am giving the extra part how it comes out, but this derivation is not included, rather it is in class 11. So if you are interested you can check it out, otherwise you use directly this relation, f equal to r by 2. So this is all about. Please go through and try to find out your doubts and make the things clear. And few things already you know, and few new things you must have to study if you have to make it clear. And this derivation is not required for your syllabus, you will get in class 11 or class 12 maybe, but class 10 you have to use directly this relation, f equal to r by 2. And if you are interested you go through, no problem, more you will learn is better for you. Thank you.